Okay, on to the third video for the C1 sequences and series questions. We've got an arithmetic sequence formed by how far an athlete prepares for a race. So we're told in the question that for the 11th term he runs 9 kilometres. So using UN equals A add n minus 1 D, we're told that the first term is A and the common difference is D. The answer to the 11th term is 9. So we have 9 equals A add 11 minus 1 times D. So 9 equals A add 10D. So that's our first bit of information. We're also told that he runs a total, so that would be Sn. Sn equals n over 2a add n minus 1 d. Over the 11 days is 77. So 77, we know that n is 11, so we've got 11 over 2, 2a add 10d. We can multiply this out to have 77 equals 11 times a add 11 times 5b. So that means 11a add 55d equals 77. If I divide by 11, I've got a add 5d equals 7. So we've got two equations now. If we can solve both of them for a and d, so we've got 7 equals a add 5d. If we do equation 1, take away equation 2, we get left with 2 equals 5d. So d equals 2/5. We stick this back into either equation. I quite like 2 at the moment, so I'm going to sub d equals 2/5 into equation 2. So we have 7 equals a add 5 times 2/5. So 7 equals a add 2. So a equals 5. Always, if you have time, it's worth double checking. If I put it into here, I've got 5 add 10 times 2/5. So that's 5 add 5 add 4, which is 9. So it is correct. Right, on to question 11. Part A says find an expression in terms of n for the number of sticks. So basically we need the nth term. So we've got the first row is 4 sticks, the second row is 7, and the third row is 10. Common difference is 3. The previous term would be 1. So the nth term is 3n add 1. Part B says the total number. It wants the total number for making 10 rows. So we're going to use Sn equals n over 2, 2a add n minus 1 d. And the numbers we're going to stick in for part B, we've got the first term is 4, the common difference is 3, and 10 rows, n is 10. So Sn equals 10 over 2 multiplied by 2 times 4, add 9 times 3, which is 5 times 35, which is 175. Okay, on to part C, where it says show that k satisfies the following expression. It tells us that she's got 1,756, so that's our Sn. She continues to make the pattern. We don't know n, so n over 2. 2 times the first term, which is 8. And the common difference is 3, so we've got 3n minus 3. So this becomes n over 2, 5 add 3n. If we multiply that 2 up and bring everything onto one side, we end up with 3n squared add 5n minus 3,500. This factorises, if you persevere, to 3k minus 100 and k add 35. Bear in mind we were given this in the question, so it wouldn't have taken a rocket scientist to be able to work out that this factorises into these two brackets. For part D, and it does say in the question, obviously, we're not going to have a negative k because it's the term number. So we've got k is 100 over 3, or k is minus 35. So it can't be minus 35. So the whole number that k could be is the 33rd term. Thank you. Okay, on to question 12. We just want the 200th term. So we know that n is 200, a is 5, d is 2. Stick it all into un, and we have 5 add 398, which is 403p. Okay. Part B, total savings, Sn equals n over 2, 2a add n minus 1d. So we have 200 over 2, 2 times a, which is 10, n minus 1 times 2, 199 times 2. This gives us £408 as the total for the 200-week period. Thank you. Okay, moving swiftly on to question 13. We've got the first term as 30, common difference as minus 1.5, or minus 3 over 2. Might make life a little bit easier later on. To find the 25th term, we're going to use un equals a add n minus 1d. So part A then, we've got 30 add n minus 1, so the 25th term, n minus 1 is 24, times minus 3 over 2, which is 30 plus minus 36, which is just minus 6. Part B, but the rth term is 0, and we need to find the value of r. So we've got the first term, 30, add n minus 1 times minus 3 over 2, and that is equal to 0. So we've got 30 minus 3r over 2, add 3 over 2, and that equals 0. When we manipulate this, we get 63 over 2 minus 3n over 2 equals 0, and we get that n equals 21. Part C says the sum of the first n terms is Sn. Find the largest possible value. Okay, so the 21st term we're going to be using. So we've got S21 equals 21 over 2, 2 times a, add 21 minus 1 times minus 3 over 2. We get left with 21 over 2 times 60 minus 30, which is 21 times 15, which which is 315. Thank you. Okay, right on to question 14. It's a lovely show that the fourth Sunday she runs 11 kilometres. So we know that A is 5 from the question. We know that D is 2 from the question. We know that N is 4, and we just need to prove that the fourth term is 11. So we've got A, add N minus 1, that's 3 times 2, and that is 11. Part B, finds an expression in terms of N for the length of the training on the nth Saturday. So we've got 5, add N minus 1 times 2, which is 5, add 2n minus 2, which is 3, add 2n. That's the nth term. Part C, show that the total distance is this. So we're going to use Sn equals n over 2, 2a, add n minus 1, d. Let's go down for a bit more space. Part C, Sn equals n over 2, 2 times the first term, add n minus 1 times 2. This simplifies to n over 2, 8 add 2n, which simplifies to n bracket 4 add n. Conveniently, this is just what we were asked to find. Part D, find the value of n if on the nth Sunday she runs 43. So we've got 43 equals 5 add n minus 1 times 2. Go back to the nth term. This gives us 43 equals 5 add 2n minus 2, which is 3 add 2n, so n is 20. Okay then, for part E, we've already found the expression for Sn. It's n multiplied by n add 4. If we know that n is 20, this is just 20 multiplied by 24, which is 480 kilometres. Thank you.